Greetings, sentient being. Today we are going to learn how to make an exploit tool in the video game Greyhack. Quick disclaimer, this is not real hacking, so you will not learn that here. Sorry, not sorry. All languages are programming. Well, not necessarily all languages are programming in the absolute sense, but all languages are programming like English, Spanish, Hangul, bees dancing, dolphins chirping, whales singing. All of these languages attempt to convey data, information, and instruction. Kind of the difference between spoken or chirped or danced languages as opposed to a computer language is the computer doesn't have much of a choice, whereas people and bees and stuff can get the message and then maybe they follow or maybe they don't. You know what I'm saying? But languages are a way to convey data and give information, like a function. Like when you tell someone how to churn butter, for instance, part of the process is telling them to perform a particular act. The up and down motion of a big churning stick on a loop until a condition is met, the butter is made. In programming, this is called a while loop. Other loops can be like a do while or a for loop or something like that. So pretty much all programming languages have the following basic concepts. You've got variables, you've got loops, you've got functions, then you have your specific syntax and convention, it's the grammar, the way you form your sentences, it's the way you form your lines of code, where you put your braces and parentheses and whatnot. And then structured data, classes and objects, pretty much everything after C has some sort of structured data that they call like a class or an object or something like that, and then C itself, they didn't have that back then when it was made, so they kind of made these things they called structures to structure data, and then those structures are the grandparents of your classes and objects today. Okay, so a variable is like a box. You put things in it. A standard variable, it holds one value, so it's one value per variable. It's like the label and the thing inside the thing. So a jewelry box, for instance, would be the variable name, jewelry box. It would be the label. And the jewelry box's contents would be the value of that label. So jewelry box equals whatever the contents were. But that's kind of clunky, so we might want to be a little more specific about those contents. So we have different types of variables to handle different types of data, like a list or a map. A list is like a regular variable that holds other variables in, a list. A map is like a variable. A map is similar to a list, but it stores its values a little differently. It's indexed a little differently. So in a map, each thing in a map is it's a key value pair, and in a list, everything's in a numerical order. So you reference it by a number. So a third item in a list you would reference as list item number 2. Since we start counting at 0, the third item's at index 2. Now in a map, you would reference an item by its key. Conversely, you can also reference a key in a map by its value. And both keys and values may be of any data type, string, map, integer, list, even a function. And it might sound weird to set a key, which is an index, as a function, but you can if it is useful to you, I guess. In a class, in programming terms, is an object that has properties and can inherit properties from a parent object, and of course pass those properties on to children, which sounds a lot like biology, but I promise we're here for programming. Okay, remember this. A class defines an object, and an object is an instance of a class. Okay? Think of this. We make a class and we call it burger. We would create it basically like you see on the screen. Burger equals some braces. And that's a map. It's a map. A map becomes a class through intent. Kind of like witchcraft. When you decide that the map is going to be a class, it suddenly is. Wow! But it doesn't look much like a burger yet, so let's fix that. So now our burger has a few attributes. We have toppings, fat percent, and meat type. generally speaking, beef burgers, you got your 15%, 85%, for standard beef. And that's our burger class. We could make a new burger very easily with a my burger equals new burger. And my burger would inherit all of these attributes, and then I could add more attributes to it, like my burger dot freaking I don't know, price. I give it a price equals $100. Who knows? And then that's my burger. It's how it differentiates itself from the parent, I guess. Inflation's kind of messed up, so it's a really expensive burger. But generally speaking, this creates a burger class that defines the burger's properties. And the convention is to make like an internal class capitalized and child classes in either lowercase or camel hump or underscored or something else. It's not my place to tell you what to do, so figure that out yourself. Once you make a class in Miniscript, you use the new keyword to make an object. To be specific, a class defines an object, and an object is an instance of a class. So you make a object from your class. So you can see something else I'll show you. There we go. Now the Wagyu burger has identical properties to the regular burger. We need to fix that. There. Now our Wagyu burger has a few more specific properties. You'll notice I didn't change the burger meat type. It is still beef. Wagyu is still beef. But the fat percent is now 25% instead of 15%. And we have some, I would say, a little more fancy toppings. Pretzel bun, crispy onions, aioli, kimchi. That's going to be a good burger. It's going to be a good burger. But it inherited its initial attributes from the parent class. Okay, so these don't travel back upstream, but it still has this, as part of its data structure. Okay, so new way we can do this is my burger equals new Wagyu burger. We can make a new version of the class that we had. And in this version, we're going to add an additional function that allows us to customize our burger. So this way we customize our burger by just completely changing the string of options, or the list of option strings. And in this one, we're going to use a little function to do some replacements. Okay. So self.toppings is going to be basically my burger dot toppings. It's going to be this list right here to start out with. And we're going to grab the index, okay? We're going to grab the index of this, which is going to be 0. We know it's going to be 0, but we're just going to say, instead of just putting, 0 there, we're going to explicitly say the index of this specific thing that we want to replace. And we're going to replace it with a manto bun. And then we're going to go with self.toppings, same thing, grab the index of the bottom pretzel bun, which we don't even have to count. We can if we want, 0, 1, 2, 3, but we don't have to know that. We can just say the index of that, okay? And it's a list, so it's going to look for this pattern, and it's going to say, well, the index is this, and it's going to return that, and then that's going to be the index that we're changing to bottom entered bun. And then we're going to call that function right after we get our new Wagyu burger. We're going to call it so it's immediately customized. Here we've done something a little different. Our parent class now has an initializer, so it takes care of the new, makes attributes, and then returns a burger. So we can actually skip that whole middle part and directly order a Wagyu burger with our preferred toppings. So my burger is now burger.init, which means run this function right here, and we're going to pass a few parameters: brioche, crispy, aioli, hold, Wagyu, and 25. Now if you look up here, you'll see we have sesame grilled, mustard, dill, beef, 15. Okay, so what we get here in this function is bun, onions, dressing, pickle, meat, fat. So that's the order that you have to send the parameters in. So the bun, brioche, onions, crispy, dressing, aioli, pickle, hold, meat, Wagyu, fat, 25. So it just starts out here. We change its properties right here. It plugs all those in and it returns the new object, which is my burger, with my custom toppings, and I didn't have to do all that middleman weirdness. I simply instantiate a new one, initialize it, and boom, we're done. Now, once I've made or instantiated my new object, I do have the option of removing attributes from it. So after I instantiate it here, I can simply remove the pickle attribute entirely if I would like to, so that it's not even an option anymore. Another way that you might instantiate a map or a class is to simply write it out in full map form, which is parentheses or brackets, your braces or whatever you call those, and then you've got a key and then a value pair separated by a colon, and each key value pair is separated by a comma, and then you end with your braces. So you just make a map inside of it, and it has all the same functions. Now, adding a function to this way would be cumbersome, to say the least. So I recommend in those situations to just make it outside like normal is your function. Just make it outside like normal. All of this allows you to make classes and objects with unique and useful properties, organized in an intuitive, easy to follow and read, portable way. Hopefully, if someone includes your class in their code, they can just fire your code by referencing your class instead of weaving your code into the fabric of theirs like some sort of fungus. No offense to fungus. But this brings us to the meta-exploit object and other game objects. So now the meta-exploit object is the meat and potatoes of the hacking in the game. And it has an API, of course, as you can see here. It has load, net use, scan, scan address, sniffer. Here, let me copy these into the thing over here so you can see them a little easier. But it has these functions: load, net use, scan, yada yada yada, and that's what you're going to use in order to get all the things you need to get in the game in order to make your exploit tool work. But the first line you start with is the include lib, and you include whatever path metaexploit is. Metaexploit can be metaexploit.so can be in any path you want. You just got to make sure you include it properly, and then save it to a variable so that you can use that variable as the class object there. So metaexploit, if you wanted to load a library that's in lib, like you want to exploit, say, init.so in the lib folder, you would do something like, well, once you've get rid of that, you would do you're going to get a metalib from metaexploit.load freaking init.so. Alright, so that's first gonna get your metaexploit object, give you access to the API, and then through that API you're going to use the load function to load in that metalib, and it's going to give you a metalib in return. And I can show you what that looks like here. So we're going to go ahead and look at it. Supply an argument for path. We're going to go lib init.so, and we get an object of type metalib, as you can see right there. And a metalib has functions overflow, lib name, and version. And you can look up here in your either in manual.exe at the scripting section, or right here in the code editor, you can find metalib, and you can see those same exact things: lib name, overflow, version. Okay, so if we go down here and we look at version, it's going to tell us the version is 1.0.8. So we already kind of knew that right there, but that's where your hack tool, or your exploit tool, is going to find that information. It's very important. You're going to want to know that information. You're also going to want to know the lib name. You're also going to want to be able to overflow it, because this is where the magic happens. So instead of going to the hack shop and downloading a new script every time you're trying to hack something new, which can get super expensive and annoying, you're going to want something that can just get those values for you automatically all the time for free, preferably, right? Right. Okay. So we know how to import our metaexploit lib, and we know that it has an API that allows us to use certain functions to do certain things, and those allow us to get and manipulate a metalib object. So the next thing that we're going to do is we're going to scan that MetaLib object. So metaexploit.scan MetaLib is the thing that we're going to do, and that's going to give us a list of vulnerable addresses, and I'll show you here. Okay, so we're going to do scan. That's 2 right there, and it wants a MetaLib, and I've already saved this MetaLib as a variable in my clipboard, and I saved it under A, so I'm just going to use @A in order to reference that. Press enter now, and it's going to scan as if we were running a regular scan, and the result is a list. When we run that function right here, this now vulnerable addresses is a list, and the list is a bunch of strings, and those strings are addresses that we would then scan inside of this MetaLib to get more information. So we're going to do that next. We're going to go back to here, and then we're going to go to scan address. Okay, and scan address. There we go. Let's enter, and we're going to use that same MetaLib as we had before, and now we're going to give it an address, and that was one of the things up here. So let's just go with the first one. Copy that. Oops, almost. There we go. Copy. Alright, and alright, so the first parameter was an object. It was a MetaLib object, and the second parameter is a string, which is the address, and that gives us the result is a string, and it is it's all the exploits for that particular address. So this little highlighted string right here is the unsecure value, and the address that we scanned, this right here, that's the memory address. So to fire this particular exploit, we would do this. Okay, back, new day, new crisis. Anyway, it always says that I'm here on Monday, which is hilarious because this has been I've been filming this over like I think a week now. Always on Monday in the game time. Anyway, so to fire an exploit, what we need are a few things. Like I said before, we need a vulnerable address, a bad string, and an inject. And in order to get those, we scan addresses to get those. So let's run what we've got so far. Metaexploit, MetaLib, address list is what we're going to get first. And then we're going to scan that first address, the first address in the address list, and we're going to get the list of strings. So we're going to go ahead and build that. There we go. We're going to go with a little my program. We're going to run it. It's going to, first thing it's going to do, it's going to do the scan. Like right there, you see it did the scan. That's the loading bar, and it's asking us to press enter, and it tells us the first address. So the first address that we're going to use is that right here. So we're going to just go ahead and grab that, copy, and we're going to put it right there. So we know our vulnerable address that we're going to try first. Now let's see all of the bad strings at that address. It's the next step. So we're going to press enter, and it's going to search through the unsecure values to get all of the, once again, bold strings. You recognize these? Bold strings. So we're going to pick the first one, because that's what we're going to do down here. So first thing we're going to do is we're just going to grab this guy right here. Actually, that's going to fail. We already know it's going to fail because it's checking for 3, and there are not 3 users. So we're going to do this one instead. Now, remember, for this particular memory address, we can use any or all of these. So we're going to use this one, check root active user, since we know we have a root active user. That's me. All right, so that's our bad string. There we go. And for the inject, we're not really too worried about this, but in the event that this is a password change exploit, and an exploit is this. So these two values combined, that's an exploit. It will produce, each of these is an exploit. It will produce something. We don't know what it is until we fire it. So we're going to do that. Our payday, the thing that we get from firing this, is going to be stored here, and we're going to overflow the MetaLib at the vulnerable address using the bad string, and the inject is going to be the password. Okay, and then we're gonna print the type of object that we got. Okay, So we're going to go ahead and build this. And there we go. We're going to clear that out of the way, and we're going to run our new program. It's going to scan. Same vulnerable address there. And now we get the strings, and we're using this one right here, and let's see what happens when we do it. Nothing, because I forgot to remove the exit, so always proofread your code. Okay, let's try this again. Vulnerable address, big string of bad strings, and we start the attack, and we failed because it requires a non-root user on the computer. So if it was successful, this would have been a computer, shell, or file. It wasn't successful, we got a null. But if it is successful, let's talk about what happens in those cases. Okay, so when an exploit is successful, it's going to return some type of an object, and the ones that you generally want are the shell, computer, and file objects. The other types of returns, as we discussed, you can get as a null or a number, and can't really do much with those after the fact. So if you get a shell, a computer, or a file, you're going to have certain functions. If you get a shell object back from an exploit, it's the same as if you got a shell using the get shell function, except it's for the target that you're targeting. The computer object you're going to get from a shell object, just like shell.hostComputer. If you get a computer object back from a target, it is as if you got this part. And of course, a file object you get from a computer object by giving it a path. Okay, but you cannot walk back up. You can't go to a computer object from a file, and you can't go to a shell from a computer, but you can get a computer from a shell, and you can get a file from a computer, and of course you can get a file from a shell, since you can get a... So, the shell object, what does it do? Well, most things that you need to do in the game you do with a shell object or something that you get from a shell object, namely a computer object, which can then give you a file object, which can give you access to the entire file system. Okay, so what most people are using it for is start terminal, so that they can jump on a new machine and start terminal and start plugging away. Also, Connect Service is what you use for Secure Shell and FTP, and SCP is of course how you upload and download things using the shell object. Build for compiling your programs, launch for launching your programs. You can only launch script functions. You cannot launch .exe functions or programs using launch, only scripts. Host computer, again, will give you a computer object, and ping you can use to ping an IP address, and then these two are not available to players. These are admin only functions, and I'm pretty sure you can guess what exactly they do based on their names and why players don't have access to that. Now again, you can see all of these functions if you explore the object itself, something along the lines of shell equals get shell for func and shell print func and for, and it won't give you this nice and neat output. It will give you a big long string of crap. I'm pretty sure you can also, I think you can get that with just something like this. Let me check real quick. String print. I don't know if that's actually going to work, but we're going to try it. Yeah, no, it didn't work. Okay, so we're going to have to do something else, which is more along the lines of for thing in shell print thing and for. Stop. Okay, so as you can see, it'll print out, basically the contents of the map. It's a big long string. It's a little hard to read, so you're going to want to parse through that with some code to get it into a nicer, neater, format that looks a little easier to read. something like that. Okay, so once you got a shell object, like I said, you can do different things with it. You can ping an address if you so desire. You can get a computer object, like I mentioned before. And once you get a computer object, then you can do computer object things. So computer objects have different functions. They're more, computer related. So let's take a look at those. All these guys right here, get ports, public IP, local IP, touches for creating files, show procs is like, PostScript, it'll give you the processes running, creating and deleting users and groups, closing programs, checking Wi-Fi, all those good, wonderful things that you can do. You do that with a computer object. So if you have a shell object, you can get a computer object and do all these things and all the shell things. If you have a computer object, you cannot get a shell object from that. You can't go backwards. You cannot go backwards, sorry. But you can get a file object. And if you get a file object, you got to give it a path. And here we're going to give it the, I don't have a password file itself, but it would be an etc. So we're just going to give it that. Okay. And that's going to go to the buffer again. And now we have a file. It's a root level file because we got it from a root level computer, which we got from a root level shell. Okay. So we got ourselves a root level file. And we can look at the properties of the file using the file object API. So if you look over here at computer and you go here to file, takes a path, returns a file. So when you go to file and look at the API for that, you have all these functions where you can manipulate files. And do I have, I have this one set up for that. So you can copy files, you can move them, you can rename them, check their path, get folders, file operations. Makes sense, right? If I want to know the size of this particular file, it's going to tell me that it's 3,947,519 bytes. Cool, right? Right. Okay, so that's shell, computer, and file, and obviously I didn't go into too much detail on each one. You're going to want to explore all these, and it's pretty, I feel, self-explanatory for each one. When you want something with a file, you're going to use the file object. So one of the things that's most important for file objects is when you want to get email information. So what you're looking for there is mail.txt. And mail.txt is usually in home, some username, and then it's going to be in config, and then it's going to be mail.txt. Okay, so the file that you're going to want to get is that file, right? That's the file you want, and you get a file object using, that's right, you guessed it, host computer, and you get that with get shell, right? So get shell.hostcomputer.file path to the file that you want. Okay, so if you get a computer object or a shell object or a file object, you are able to find this. Okay, so if you do your overflow, to put in there, right, so your result is that, and your result, if type of result, okay, is a computer object, such as one you might get from a bounce exploit, then you're going to do this. Remember, if the result's a computer object, we have the get shell.hostcomputer part. Okay, that's the computer. That's our computer object. We're going to use that to get a file straight from that directory. Okay, it doesn't matter what where. It doesn't matter. We're just going to go straight. If we know the username, we're going to go straight to that directory and get it. If we don't know the username, we have to do some other stuff. But we're going to assume that we already know the username that we need to get the email address from. That's going to get it for us. Okay, so we're going to store that in a variable, of course. The email equals that, and that's of course going to be encrypted, so we're going to have to decipher that information. So we're going to have to get, we're going to have to get a separate program to do that for us. And in order to do that, you're going to need to get that password. So in here, in mail.txt, it's going to be along the lines of name at domain dot what the fuck ever, I forgot what that's called. I'm not going to look it up right now. So name at, and then it's going to have a colon, and then it's going to have a 32 character hash string. I'm not going to type them all. It's going to be a 32 character hash string. You feed that to Decipher, and it spits out the deciphered password. Okay, and then you use that information to get into someone's email address, and then use that email address that you hacked to send the funny game email to another user on the network. You use the so what you're going to do is open up mail over here. First thing you're going to do is you're going to use this to log into the hacked user's account using that password that you got. And then once you're in there, you're going to send the funny game email using the IP import of your attack server running the, hopefully, running the R shell server that's going to let you interface with that. And that'll be in a different, that's out of the scope of this lesson. Okay, so once you've got an object, generally speaking, you're going to use that object to get information that you want. So if you got a shell, you're probably going to either use that to get information, because you can also do something like this. And then it's going to be a user colon hash pair, and then you send that hash to Decipher and get the password. And a pro tip for you, since you watched this long into the video, I'll tell you the root password of the gateway router is the root password for the whole network. That means all machines have the same root password on untouched NPC systems. Obviously, if a player goes in there and changes the password, then that's not the case. But when an NPC system spawns, it spawns with the same root password for all machines. So if you find the root password on one machine, it's the same root password for all, which is super, super handy. Okay, so if you get a shell, computer, or file object on an NPC machine, you should be able to automatically get the email addresses of the user, since they're pretty much always readable by guest. And then most of the time the password file is readable by users on the system. It's not always only readable by root. Sometimes users can read it. It's rarely readable by guest. But users can usually read it that are in the root group, for instance, or the system group. And then of course root can always read it. Use the objects you obtain to do the hacking. Getting the object is only part of it. Using that overflow is only part of it. That gets you in the door. That gets you the object. Once you have the object, you have to do things in order, to continue on your mission. So if your mission is to, for instance, change the grades of a user, you're going to want to get onto a machine with a shell object and start the terminal on a machine on that network that has the student viewer GUI app, and then open it up and do that. And then you're going to want to clean your logs somehow and then disconnect and that sort of thing. If your goal is to remove a file, you can do that with a user or root level file object. You don't necessarily need a shell or computer object in order to remove that file, because you can do it with a file object itself. Any file object can allow you to get any other file object on that machine. Okay, so last thing we're going to look at here is port information. So port information and router information, that's basically how you're going to get your InMap tool, your port scan tool, whatever. If you want to make a custom InMap, you're going to need whois, you're going to need the router object, and you're going to need port objects. So whois is just going to give you domain name, administrative contact, email, phone. So, basic stuff, and it's a general function. It's not a router or a computer or shell object function. It's just a general function. You can just get that with just like who is fucking IP. That's all you got to do to get that. And it's going to give you a string. Okay. Now, the router object is actually, that's your router. That's the gateway to the network. So if I were to probe that particular network, there's my whois information, and then I did some magic to do this. I got some firewalls from that, but right here you got your gateway computer. Okay, and so that's going to get you. That's your router object. That's going to get you that. From here, once you get a router object, you have certain functions that you can use, and those are right here. You can get public IP info, kernel version, firewall rules, BSSID and ESSID name, IPs of devices on the network, that sort of thing. So you get all these. All this information is gotten from the router and port objects. So a port, when you get a router, if you want to get the forwarded ports, what's actually forwarded to the outside. This has no forwarded ports. So let's get a random one. This one has forwarded 3306. So you can see 3306 for this IP address is routed to the internal 3306 port of that machine. So it's the same port on the inside and the outside, but you notice over here you've got 192.168.0.4. That's a machine that's on the network that has two ports open, 80 and 37777. Those two ports are open on this machine, but they are not forwarded to the outside. You would not be able to reach this machine from the outside. You'd have to bounce through the router and do social engineering and that sort of fucking thing. But to get this information, you still get it from the router object. So I get a list of forwarded ports from here, and that's going to give me that information. And then ports on a specific machine, well, that I get from, let's go over here to the router object again, and I get devices LAN IP. Okay, is going to give me information on the LAN IP, shits that's on the network, and then I can loop through those and request port information from each of those. So I get, device ports is going to give me the IP address. So I get devices LAN IP, and then for each of these, I'm going to get an IP address. Okay, and then I'm going to use that to get a list of ports, and once I get that list of ports on that machine, which is this right here, it's going to be a list of ports, I go through that list and I can do something like print the port number, get the LAN IP, that sort of thing, so I can associate that port with that machine, even though it's not forwarded, and then I can get this information. Pretty cool, right? Alright, so summary. Router object is going to give you a list of port objects, and then using the router object functions, device ports, devices LAN IP, that sort of thing, port info, you're going to get information on the port. Oh, that's the other thing. So let's see, info string is going to be equal to router.port, info, and then you're going to send it a port object. Okay, and again, you get the port object from the list of port objects returned by one of these two functions. This is going to get a list of port objects. Okay, so if you use the router and you pass it a port object, it'll give you the port info, which is this information right here, the service and version that's running on that particular port on that particular machine. Okay. Okay, super long video. If you're still here, kudos to you. I'm kind of hoping you did this video in a bunch of chunks instead of trying to slog through the entire thing at once. Also, I apologize that some of the examples were a little hard to follow because you couldn't just compile them right away because we kind of stepped through them without completing them. But promise you, now we're at the part where we're going to write programs that you can use, and it's actually going to be homework for you. So what I'm going to do is I'm going to show you this here stub, and I want you to fill out the meat and potatoes, the important part of the, I just got charged bank fees, but that's cool. The important part is how do you get those bad strings? Like how do you go through that big string that we saw and get out all those bold strings from there that you're going to use? So again, MetaLib or meta exploit, and then you're going to get a MetaLib. You can also get, net set. If you get a remote MetaLib using a net session, you just use dumplib. You get the MetaLib, and it's the exact same process as before, just with an IP address instead of with a MetaLib. Now, your vulnerable addresses, again, you're going to get that whole list, and then you're going to go through that list. For every address in the list of vulnerable addresses, there's going to be a big string associated with that address. You're going to get that, and then you're going to split it. And I want you to figure out I want you to print out that string, that big string, so that you can see what's going on, and I want you to decide where an appropriate spot would be to split that string so that you can get a chunk that just has one bad string per chunk. And then you're going to do some slice or split and index of magic to get the bold string out of each chunk. And then what I recommend, just to make it easy, is each time you do that, you're going to run your overflow after you get each chunk or each bad string, and you're going to just run the overflow and push the result to a list. Okay, we're going to make ourselves a little list, and we're going to put all of our results in that list, and then once we're done, we're going to handle them. So I wrote a little class to handle objects, whether it's a computer, a shell, or a file, a shell, computer, or file, and I didn't really flesh them out. Just one return, one little thing that it does per thing. You're going to want to take this and flesh it out more. Maybe throw some menus in there, that sort of thing. But in this simple example, we're going to go through the whole result list and handle each object. Obviously, if it's a shell, it's going to start terminal and it's going to end the program. But like I said, it's a stub. Fill it out how you want it. The important part is right here. Figure out how to get those bold strings. So pause the video, go get yourself something to drink and eat, come back, work on your homework, unpause the video, and I will show you what mine looks like. And then you can compare notes, or you can just skip ahead and just copy what mine looks like, and then you can just get started and go. But you're still going to need to flesh out these examples because I have not shown you full hacking tools. I have only shown you all the pieces that you need, and then it's up to you to take all these pieces and put them all together. And then maybe I'll do a second video where I just go straight through making a hacking tool. We'll call it like a speed build or something like that, where it's less talking, more typing. All right, so pause the video, do your homework, and then come back. And I'm going to sit here and play blackjack while you do that. Do a little bit of blackjack. Let's see, we're going to bet 10. We got a 19, we're going to stay. Dealer busts, I win. Alright, we're going to bet 20. I got a 21, I got blackjack, time and a half. I'm going to bet 30. I'm going to have to hit a 24, I busted. Damn. Alright, got to bet 50 now. Ooh, dealer got lucky is what he got. Alright, 21, push, oof. Alright, let's try again. I got a 17, dealer's got a 14. I got an ace. I'm going to hit. I got a 17 again. I better stay while I can. Dealer busts. I win. Alright. We bet 60. 17. Ooh, fuck. We got to stay on the 17. 17. Push. Alright. Good, good, good. 60 again. 14. Ooh, I have to hit. 21. Alright, we're getting lucky here. Bet 100. Alright. Ooh, fuck. Okay, we hit. 14, hit. Dealer 18, 18, push, right? Oh, no, it's a soft 18. Dealer busts. Alright, dealer hit on a soft 18, dummy. I probably should have programmed him to stay on a soft 18, I think. Anyway, we're going to bet 300, and we're going to stay. Dealer is going to stay at 17, and we win. Alright, we're going to go all in. And we're going to hit on a 12. We get a 19, dealer gets a 16. Because stay. And we win. 1240. Alright, well, let's go all in again. 14 on 14, hit. Lose. Game over. All right, you should be done with your homework by now. So let's check notes. All right, so I'm going to minimize this one. I'm going to put this over here. We're going to get this guy up here. And it's the wrong one. So, yeah, that's the one you want. Okay. Okay. All right, so let's see what mine looks like. Let's see what yours looks like. All right, so the same things, including meta-exploit, meta-lib, addresses, print our addresses, make a result list, and we're going to... Why did I do that? Oh, I remember, because I put an extra doohickey in there, if result, and we have to... Okay. Anyway, so for address and addresses, remember, let's get our other one up so we can compare. For address in vulnerable addresses, we're going to get our big string, and we're going to print it. We don't really need the debug lines in there, do we? All right, so we're going to get our big string, and we're going to split by unsafe check. Okay, that's the first thing. Right there. We're going to split by the word, and this unsafe check with that space in there, the little colon in the space. You want that, and that's going to split it into chunks. And then we're going to skip that first one. If you print out that chunk, you'll see the first chunk we do not want because it doesn't have bad string. Starting from the second chunk, the bad string is going to be, we're going to take a slice, this operation right here of, let me get a little scratch paper so you can see, if you have a string and then you use brackets and then you have a colon in the middle, this is slice. You can slice from index 1 to index 2. You can take a slice. Another way of using the slice doohickey is here, string, index 1, index 2, and this is also valid. And both are going to return a string that has been sliced. It's a new string that it's going to return. You can also slice lists the same way. And it will return a new sliced list. Maps, on the other hand, I'm not sure if you can slice those or not, so you might want to check the documentation on those. I've never tried to slice a map. But anyway, slicing your string from the index of the bold tag plus 3. So the index of the bold tag is going to be here, and we want to slice it from here after the index, or after the bold tag, so it's 3 characters long. So we start at the index, which is here, and we count up 3, and that's where we slice it from. And we slice it from there to the end of the bold tag. And this index 2 is where it stops, so it does not include the bold tag. It slices from here to there. So it excludes the bold tag and just takes the string in the middle. Then I did a little bit of a trim here. I don't think this is actually necessary. I think that was just me being weird. But if you get wonky things, just go ahead and throw that line in there and it'll fucking work. Anyway, I'm going to print what I'm doing. So I'm going to say that I'm exploiting this address with this bad string. And I'm going to take the result using that address and that bad string. And if the result exists, I'm going to push it to the list. So now over here you might have noticed that I didn't do that check. I just pushed it straight into the list. If the result is null, you're going to have a whole bunch of null objects in the list. So this one's just going to filter those out so that only actual objects go into the list. Okay? And then if you got something that's going to say, you know, we got null or computer or shell or whatever. And that's it. So you 2 for loops, 1 to get the addresses and 1 to get the chunks out of the address and get the strings. Fire the overflow results. Then once you got something, you got a whole list, remember, of results. And you know, there's our handler. And I printed a little menu so that instead of looping through like we did over here for every result, I'm going to print out a menu that shows all the things in the result list. For result in result list, it's going to print the type of result and a little number next to it. And then I can do a little menu using user input, and then I can, you know, just kind of get a selection, and then you know, just kind of send that to the handler, and brings us to the very final thing here. You got your pointer is going to reference this map here, this handle map right here, and I'm going to show you why we're doing this instead of explicitly saying if shell then do this, if computer then do this. So if the type of it's a number, then we're not going to do anything. It's just a password change thing. We didn't have an object that we handle. If it is an object that we handle, then what we do is we make a pointer for our handler, and we're going to use the @ symbol to do that. It's a reference to the memory address as opposed to the thing itself. So it's a reference to what's in the address as opposed to, or I'm sorry, it's a reference to the address as opposed to what's in the address. So what we do is we get a reference to shell, because this type of is going to return a string, and you can reference a map index like this. Okay, so since I have handle.shell, I can reference handle.shell as handle brackets shell. So when I reference at handle brackets shell, then this is a reference to this function right here, and then I just pass it an its object. So this is the same as running this. Okay, so you pass it that, and then it's going to return whatever you have. So if you have a file object, it's going to say, well, this is a file object, handle file object. See that? So it's dynamic. If none of these are an option, it's just not going to fucking do anything. Or actually, I'm sorry. If neither of these are an option, it's going to barf. But this is all deterministic because we know there are only certain results that we can get. And we know that if the result doesn't exist, we're going to get rid of it. So then it's either one of our 3 game objects or it's a number. So if it's a number, we do this, and then if we've gotten all the way here, we know it's either a computer, a shell, or a file, so we know the index is going to exist. So we don't necessarily have to put error checking here, but it's always good to put error checking. But for this particular scenario, it's all deterministic. We know exactly what we're going to get here. So error handling is not necessary. But this is just an easy way to handle your game objects without using if shell then do this, if computer then do this, if file then do this. It's just like if it exists, pick the appropriate one. Okay, and then you're going to want to flesh these out, maybe put menus inside of these, so that you can actually do stuff with those objects. Or you can write an entire shell that incorporates shell, computer, and file objects all into one thing, where you can just type as if you're typing in the terminal and control a machine that way, which is what which is what mine does. It's just a shell, and you have all these commands, and then you just do stuff. It's a shell. Okay, that's that. Okay, so what does it look like? Let's go ahead and take this and fire it and see what happens. So we compiled it, we called it my program, we run it. It scans, it prints. So it goes through, and these are all the chunks that it found, because it found each of these addresses. And so it's going to dump a chunk for each one, and it's going to go through and run all those exploits. So the first address goes through, does all those, next address, fire, next address, fire, next address, fire. All of that most of them were null, but occasionally you see here we got a file, and up here, we got a computer, and then there we got a computer. And then everything else was null. So we got a computer, and we got a file. So we put those in a list, and let's just go ahead and just go with number 2 because it's the easiest, and that file that we got was the root folder. Pretty simple, right? The computer, obviously, those are both going to be the same because it was run on this machine. It's going to be this computer. But that's it. You just do that, and you fire away, and then you get an object, and then you do something with it. If we've gotten a shell, start terminal. Okay, so I almost forgot to talk about the crypto library. You definitely want to be able to use the crypto.so shell object library so that you can import or include the library and then use the crypto class functions. Specifically, decipher is kind of a big one. That's how you decipher the username password hashes that you find in / etc. password or in mail.txt or bank.txt. That's where you get those hashes from. And you use decipher to do that. You simply feed it an encrypted pass, which is a 32-character hash string, and it will decipher it. The stock, the generic one that comes with the game looks a little different than what I've got right here. And I'll show you kind of the main difference so that when you make your own, you can make some informed decisions. So the same thing, I'm including my cryptools library. If it's not there, obviously, you're going to want to check your path and make sure you got it in the right spot. This is a little function we're going to come back to, and of course parameters, that sort of thing. But we're more looking for something that's down here. So the file that we're going to look at, it's going to get it's the same thing. We're looking for the password file, path to etc. password, and it stores that using the same thing. So we have our file. Okay. If it's can't read it, yada 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 blah. If everything's good, then what we're going to do is we're going to get the content. So lines equals file.get content split by the new line. So line file split character 10 is the same thing. So get content dot split character 10. That's what we're doing in these lines. Get content dot split, and that's character 10. So that's our lines. Now for line in lines, we're going to do some stuff. You'll see that on the left, the stock decipher program, it gives you a menu, tells you to select one, and then it will decipher the one that you select. If there's more than one. If there's only one, it'll just decipher the one. Over here, it's going to just go through and do each line automatically because I haven't put a menu in there for it. But regardless of which one you're going to do, what you're going to do is you're going to split the line at the colon because it's going to be that, user hash pair, and you're going to want to store, the username, and you're going to want to store the hash, and you're going to want to send the hash itself to the decipher routine from crypto, which we import using crypto.so. Okay, so remember that's one of the methods of that class is decipher. Other methods are going to be the aircrack stuff, yeah, you can just look at the stock decipher program and kind of make yours based off of this, or you can just look at mine and make yours based off of this, and then flesh it out from there as far as what is useful to you. This right here is very bare bones basic, and we'll just decipher whatever's in the file and spit it out to the terminal. Like, it'll just print it to the screen. It's not going to do much else with it, so you're going to want to do more than this. Okay. The other tools that you've got there with the crypto class, crypto library, as it were, aircrack, airmon, air replay, and smtp user list. These three right here are what you're going to use to make your Wi-Fi cracking tool. I'm not going to show you my nearby Wi-Fi networks just so that I don't have to restart after making this video. But you would use these to crack into those Wi-Fi networks that you would find nearby, and get their passwords and then jump around to different Wi-Fi networks, that sort of thing. And then this is going to let you, if you find a machine that's got port 25 on it, it'll give you a list of users on that machine that have email addresses registered to that machine. Besides that, that's this kind of a super long video that I am going to go ahead and end here. I'll, with any luck, maybe I'll do some videos in the future that are shorter and more targeted, easier to follow. But this is just kind of the big one. Hopefully, it's helpful. Sorry that I'm just kind of a mess. Yeah, like, subscribe so that I get encouragement to keep doing these sorts of things. Yeah, thanks for watching. Stay safe.